Damped oscillations. Whenever any system is performing or oscillating in the presence of some resistive forces, then the oscillations will die out with time. Then we say that these are the damped oscillations. But if you come to the topic of friction, you have read this topic in 9th class. There are two possibilities. Either the friction is present or the friction is not present. Whenever the friction is present, the system will be called a practical system. And if the friction is not present, the system is called an ideal system. Why this is called an ideal system? Because such system exists only in our ideas. Practically every system is having friction. In our daily life, even the smoothest systems or the smoothest surfaces have friction. What is the most smooth thing that you can consider? That is air. Even air also present friction. If you take a swing and you push yourself once, you cannot take the swing for infinite time. Your swing will slow down because of the friction provided by the air. That friction is known as air resistance. Let us see that how the oscillations are damped by friction. As you all know that friction retards or slows down the motion. Whenever friction is there, the role of the friction is it opposes the motion, and that's why the force of friction slows down the motion. Like for linear motion, if you throw a ball on a surface which is frictionless, it will continue moving forever, but if the friction is there, the ball will stop at one time. Now the next thing, same is for the oscillations. Whenever friction is there, oscillations will not continue forever. Not infinite means that sometimes or at some point the oscillation will stop. They will not continue forever. What actually the friction do? The friction affects the mechanical energy. What is the mechanical energy? When the body is doing oscillations, it is moving, and because of the motion it is having the mechanical energy. Or if it is the swing, it is changing its position, is going on the top, coming back. Also because of location it is having the mechanical energy inside it. It can be potential, it can be kinetic. Well, that point is not to be discussed that much. Let us only consider the relation of friction with energy. Friction will be there all the time in same amount. When the time will pass on, that mechanical energy with which the body is moving, a part of it will be used by the friction, or a part of the energy will be used in overcoming the friction. That part, once gone, it will never come back. So as the time passes on, the friction start eating up the energy, and the vibrating body will be having less energy when the time will pass on. When the energy will become less, the amplitude with which the body is vibrating will also reduce with time. Let me show you with one example. One thing you should note, this is not the exact system which is executing simple harmonic motion, but it is vibrating. You can see that I am using this. See, it is vibrating, and with every passing moment its oscillations, its amplitude is reducing, and finally it is staying on the mean position. So this is how the air resistance is damping the oscillations right now. The next topic is shock absorbent. This is a spring. Inside the spring, the shock absorber is present. This portion of shock absorber is attached to the car axle. This portion is attached to the car frame. Now this is the outer covering of the shock absorber. Inside there is a chamber. In this chamber, this is a piston which can move up and down. Inside a liquid, the liquid is oil right now. If you want to see the piston, let me show you the one. All of you will be having the ink pen, the SP10 ink pen I am using. See, if you look at this black thing which we move up and down to fill the ink, this is the example of piston. Now when the car will move over any obstacle, this portion will take up the vibration and the vibrations will travel through the spring to the top, and this piston will start to vibrate inside the liquid. The liquid is oil. This oil will quickly damp the vibrations because of the friction which is produced by it, and that will stop the vibrations.